In today's video, we will look at a technique of integration known as a change of variable. This is also commonly known as U substitution, or for short, U sub. So in this video, we will introduce the technique of U sub and then just look at several examples of how to apply it. This technique applies to integrals of the form f of g of x times g prime of x. What we will do is we'll say let g prime of x be continuous over some interval I. We will also let little f of x be continuous over the corresponding range of g. And we will let big f of x be any antiderivative of little f of x. Now, the derivative of big F of g of x, right? This is a chain rule. So it's big F prime of g of x times g prime of x. Notice that what this means is that this is little f of g of x times g prime of x, right? This means that the antiderivative of f of g of x times g prime of x is big F of g of x plus an arbitrary constant of integration. So the technique of U sub is to let U equal g of x. Let U equal g of x, where g prime of x is continuous over an interval I. Let little f of x be continuous over the corresponding range of g. Then the change of variable says the antiderivative of f of g of x times g prime of x is equal to the antiderivative of f of u. We will now look at several examples and see how change of variable is applied. We start with evaluating the antiderivative of 6x times 3x squared plus 4 squared dx. Now, we look at this and we want to go, what is the problem with this antiderivative? Well, we don't know how to evaluate 3x squared plus 4 quantity squared. So why not say that is our u? Notice then du would be 6x times dx. Now look, 6x dx, 6x dx. So that's going to get replaced with du. The 3x squared plus 4 gets replaced with u, and so this is actually the antiderivative of u squared, which is a power rule. U to the 2 plus 1 over 2 plus 1 plus a constant, so that's u cubed over 3 plus a constant of integration. Replace u again with 3x squared plus 4. And here is our antiderivative. And we can always check that that is correct by taking its derivative and verifying that we get back to the original integrand. Next up, antiderivative of z times the square root of z squared minus 5. Again, we want to look and we go, what is the problem in this integral? And it's the square root of z squared minus 5. So let u be z squared minus 5. Du is then 2z dz. And so we have the 2z dz, but notice we have a z dz. We don't have a 2. Well, since 2 is just a constant, why don't we just multiply z by 2 and then multiply the overall integral by 1/2. Notice all we've done is multiply by 1 in this case. Well, now we have the 2z dz. So we can write this as 1/2 antiderivative square root of u du, which is 1/2 times the antiderivative of u to the 1/2 power du. That is a power rule. 1/2 u to the 1/2 plus 1 all over 1/2 plus 1. That's 1/2 times u to the 3/2 divided by 3/2. Dividing by 3/2 is the same as multiplying by 2/3. That is 1/3. Now replace u with the z squared minus 5. Don't forget the constant of integration. And we have our antiderivative. Let's look at evaluating sine of t over cosine cubed of t. Well, we certainly do not like that cosine cubed. So why not let u be cosine of t, which means that du is negative sine of t, dt. All right, so this is what we're looking for in the integral. Well, here we go. We have a sine t, we have a dt. We do not have negative. So why not multiply the sign by negative and then multiply the overall result by negative? This will now give us negative antiderivative 1 over u cubed du. Let's rewrite that as negative antiderivative u to the minus 3 du. Power rule says it's u to the negative 3 plus 1 over negative 3 plus 1. So that's negative u to the minus 2 over negative 2. 1 over 2 u squared. And replace u. We get 1 over 2 cosine squared t plus our constant. Or we can use properties of trig and write that as 1/2 secant squared t plus a constant. Either one of these would be an acceptable antiderivative. Let's now look. Antiderivative x over the square root x minus 1. if we let u be x minus 1, which I never wrote u, du would simply be dx. Well, there's a problem. We still have this extra x. Well, if u is x minus 1, that would mean x would be u plus 1. All right, so let's do some color coding. Du equals dx, we're going to replace dx with du. We're going to replace x minus 1 with u. And then we replace this x here by that u plus 1. Doing so, we will get antiderivative u plus 1 over the square root of u du. That is the antiderivative of u plus 1 over u to the 1/2. Now, that's a monomial in the denominator. That allows us to write this as u to the 1/2, that's u over u to the 1/2, plus 1 over u to the 1/2 is u to the minus 1/2. This is sum of antiderivatives and power rules, so we're going to have u to the 1/2 plus 1 over 1/2 plus 1 plus u to the minus 1/2 plus 1 over minus 1/2 plus 1. This is u to the 3/2 divided by 3/2 plus u to the 1/2 divided by 1/2. That is 2/3 u to the 3/2 plus 2u to the 1/2. U was x minus 1. So our antiderivative, 2/3 x minus 1 to the 3/2 plus 2 times x minus 1 to the 1/2 plus an arbitrary constant. And again, if we wanted to, we could write x minus 1 to the 1/2 as square root of x minus 1. That concludes this video on change of variable, or u sub. In the next video in this series, we are going to introduce the fundamental theorem of calculus. This is the most important theorem in all of calculus. It relates the definite integral, the Riemann integral, to an antiderivative. I will see you all in the next one.